In this class, now I am going to explain put of the perpendicular theorem from straight lines. Now let us see the statement of put of the perpendicular theorem. See, let QH comma K be the put of a point, put of the point P x1 comma y1 with respect to a line ax plus by plus c equal to 0, then show that h minus x1 by a which is equal to k minus y1 by b which is equal to minus of ax1 plus by1 plus c whole by a square plus b square. So this is the statement of put of the perpendicular theorem. See, what is Q? Put of a point P with respect to this ax plus by plus c equal to 0. Then prove that h minus x1 by a which is equal to k minus y1 by b which is equal to minus of ax1 plus by1 plus c by a square plus b square. Now let us see whose proof. See, draw the line whose equation is given as ax plus by plus c is equal to 0. Yes, here consider one point whose coordinates are x1 comma y1. Now drop a perpendicular from P to this line. Actually many more lines you can take from P to this line, but among all that the shortest one is perpendicular. So this is the perpendicular one, so which is meeting this line at one point. No, that is called our required point. Say it as put. Okay, what is Q? Put of this perpendicular. So this PQ is making 90 degrees angle with this ax plus by plus c equal to 0. Hence, this Q is called put of this P. Okay. Now, let us find Q coordinates. How do you find? So, let us say the slope of PQ be M1. Slope of this line be M2. Okay. As you know, both are looking like perpendicular to each other, no? Hence, product of their slopes is equal to -1. Okay? So, you know this relation. M1 into M2 equal to -1. M1 represents the slope of PQ, no? Right. You know, when you know 2 points on the line, so how do you find slope of such line? Difference of y coordinates by difference of x coordinates. Now here, what is the difference of y coordinates? H minus y1 by, k minus y1. K minus y1 by h minus x1. H minus x1 into M2 means it represents the slope of this line. You know, minus x coefficient by y coefficient. Their x coefficient is a, y coefficient is b, so that you will get this much, which is equal to -1. Now this minus can be cancelled. Okay, so here h minus x1 into b, send it to the right side. K minus y1 into a is left. When you transfer these two to the right side, h minus x1 into b. So transfer this b to the left side, a to the right side, so that here you will get k minus y1 by b, now which is equal to h minus x1 by a. Okay students, so hereafter, so for this apply law of proportion. Okay, so if you apply law of proportion, students, what do you get here? So here, in the according to the law of proportion, so this is one ratio, this is one ratio. Both ratios are equal means these two are in proportion. So, okay, so you have one law of proportion. As per that, so here h minus x1 by a is given. So if you multiply with numerator and denominator, no changes will come in this ratio. Similarly, here also. Okay, I am multiplying numerator and denominator with one more b into b. Okay, no changes will come in this ratio. So after multiplying this one with AA and this one with BB, no changes will come in this ratio. Both ratios are equal only. Means these are in proportion only. Okay. So if A by B equal to C by D, so these two ratios are in proportion, no? Then it is equal to A plus C by B plus D. So you read this property in the proportion chapter. Okay. So after this step, for this I am going to apply this formula. Like if A by B equals C by D, then these two ratios are equivalent to A plus C by B plus D. Okay. So this is equivalent to this. And hereafter, what I am going to do? Add both in the numerator. A of h minus x1 by a square. Now, plus here, put plus here. B of k minus y1 by b square. Okay, as per that previous property, a plus c by b plus d. So in the numerator plus you can add, and you can add in the denominator also. Okay, students. Now h minus x1 by a, which is equal to k minus y1 bb, is equivalent to this. Okay, students. Hereafter, let us go for a simplification. Now a into h here, b into k. Ah plus bk. And here minus ax1, okay, right, minus by1 whole by a square plus b square. Hereafter, students, where is h comma k? Lying on this line, no. So that replace xy by this h comma k. So that here you will get ah plus bk plus c is equal to 0. Okay, students. Now see here, ah plus bk. Now which is equal to minus c, because h comma k is lying on this line. Root is lying on this line, no? Hence substitute, replace this xy by h comma k, so that you will get ah plus bk is equal to minus c. Now replace this by minus c. Okay, so that what do you get? Minus c minus ax1 minus by1 whole by a square plus b square. In the next step, what you people will take as common? Minus 1 from these three. If you take minus 1 minus common from these three, inside you will get ax1 plus by1 plus c by a square plus b square. Okay, students, I hope you have understood. So finally, what you have got? Therefore, h minus x1 by a, which is equal to k minus y1 by b, which is equal to minus of ax1 plus by1 plus c by a square plus b square. Okay, students. Suppose while going for application, if you want h, what you people have to take? First and last. And go for simplification, so that you will get h. Similarly, if you want k, so equate the second and last and go for simplification, you will get k. Okay. So in the problem, they will give you x1, y1, means coordinates of p, and a, b, c are the coefficients of terms of the line equation. You will get a, b, c from line, and x1, y1 is the given point, and substitute those things in this formula and go for simplification. so that you will get h comma k is our required put of p with respect to ax plus by plus c equal to 0. Thank you.